All right. So first we're going to start today talking about operating systems, sort of classic operating system issues and how operating systems provide security and isolation between users and other processes. So first of all, what is an operating system? An operating system is the software that controls the hardware on which you're running programs. So if you have a system where you're running multiple programs like your laptop or a desktop computer or a server, really anything where it has a CPU and it runs multiple programs, you need an operating system. And the operating system is written for the specific hardware in question. So the core or the kernel of the operating system needs to be written for the hardware. So Intel or Apple Silicon or MIPS or ARM or whatever has to be written for that. And you can have an OS like Linux that runs on a lot of different types of hardware, but each of the little kernels is written for a particular processor. And the main job of an operating system is to provide secure shared access to the hardware in question. So if this is a laptop, then we're talking about, you know, the all kinds of whatever hardware your current laptop has. If it's a desktop, it's that hardware. If it's a big server with a bunch of things, whatever you have to share on a particular machine is what the operating system is responsible for. So, what are some of the kinds of things that an OS might protect or also help share? And the hint here is it's anything that can be shared between processes where different processes want to use it at different times, maybe, or between different users, or anything that it itself can affect sharing. So if you want to, you can pause the video here and try to think about what are some of the types of things, resources, or objects we might talk about inside the operating system that the operating system would need to protect. So you can pause it and think about it if you want to. So here are some things that need to be protected. So obviously memory, the RAM of the computer. You can't have every process reading the memory of every other process. That would not be secure. All devices, in particular any kind of shared I/O devices, so disks, network, video, audio, mouse, keyboard, etc. The operating system has to manage that to make sure that it can be controlled safely. Then any kind of device that we reuse serially, meaning that one process uses it at once and then another one uses it after that. So for example, printers, cameras, fingerprint readers, anything like that, the operating system has to manage all of those devices. OS also manages files and file permissions. So a user's individual data, shared libraries that exist for all programs and processes on the system, any kind of sensitive application data for a program that we might protect with permissions, any operating systems specific data, for example, passwords, configuration, the operating system itself, all of that stuff has to be protected with file permissions of some kind. Then internals of the operating system. So each OS has its own internal structures managing individual users, memory, scheduling, all that kind of stuff. If a program could modify the internals of the operating system, then the program could just disable all the security features. So the operating system has to protect itself from users and other processes as well. And then the operating system also protects what are called privileged CPU instructions and other protection mechanisms themselves. And we'll talk about those in an upcoming video. But you can just think about it. Just think, what wouldn't you want an adversary to have just uncontrolled access to? If there's anything you think would be bad if an adversary just had complete and utter control of, we probably need the operating system to protect that. And so again, all of memory, all devices, network, files, anything where we think that shouldn't just be a free-for-all. And what that leaves, if you think about it, is that each program has a space of files and resources that it can access that are specific to the user in question. And that's what we allow them to have access to. So operating systems help provide what we call separation. And there are 4 different types of separation. Separation is different ways that we can isolate programs or processes from each other. The first one is physical. So we can physically separate them so that we talked about running different services on different computers completely. That's physical isolation. We can do that. We can also air gap things so that a computer isn't even connected to a network. So one computer couldn't talk directly to another computer. That's physical isolation. Then we can do what's called temporal isolation. And in temporal isolation, different programs are run at different times completely. So the PDP-12 actually functioned in this way. So you can run one program at any given time, and when you're running that program, nothing else can run, and the program has complete control of the system. So one program can't affect another program because it's literally not present. It's not very useful in the modern world, but that's one way to handle it. We can also do what's called logical isolation, where we isolate by some kind of software illusion, some software mechanism. Commonly, this is virtualization. So we run things in a VM, we virtualize memory in some way, we provide file permissions, and of course the file permissions are just a thing that the operating system itself is imposing. It's not like, built into the computer. And then, of course, there's also cryptographic isolation, where we use encryption so that you can't actually read or see other data. The data might be there, but you can't tell what it is, and that's called cryptographic isolation. And of course, we can combine these different types of isolation. So you could have cryptographic isolation, meaning that you encrypt things and then also have them on separate physical machines. So that's like a combined type of isolation. Operating systems typically enforce logical separation between users and other programs, for example. So obviously the operating system has to be the thing that provides that isolation, because you can run hundreds or thousands of different programs on a computer at a given time. They obviously shouldn't be able to interact with each other, and so the operating system has to enforce that separation. And we do that with a lot of different features, some of which we've talked about before, like user IDs and authentication mechanisms to indicate which user in question is supposed to be running, tracking which user controls a process that we're dealing with at any given moment. File permissions, we've talked about those before. Those are logical separation. Then we'll also talk about some other things in the upcoming videos. So we'll talk about how we isolate processes so they can't take over the CPU completely, how processes can't do dangerous things. That's CPU privilege and system calls. And then we'll talk about how processes don't get to choose when they're executed and how they share the CPU, and that's called scheduling. And then we'll also talk about memory protection, how we protect the memory of one program from another program. And those are all in upcoming videos. Stay tuned.